Great. Yeah, so hope everyone can hear me okay. Let me share my screen. So welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at TwelveLabs. For those of you who are new to the series, this is our company is in startup focusing on building AI models for video understanding. This is an initiative that we've been hosting over the past almost 3 years now on a weekly basis to sharing best practices, knowledge on this exciting field of multimodal AI. Occasionally, we have researchers coming and talk about the research project. We have partners, customer sharing best practices on building multimodal application in different verticals. We have developers who are building with our API, sharing different projects that we're building, and then finally we have internal team member coming in and talk about like tutorials and guides on building with our platform and API. These are some sample topics that we cover in the most recent session. We have folks talking about, we have researchers talking about like, video reasoning. We have customer talking about using our tools for, spot highlight generation, social media, recommendation, education, etc. For today's session, we will feature three pretty exciting, application that's been built with our technology in one of the recent collegiate hackathon at University of Santa Barbara a couple of weeks ago. Yeah, the first group is going to be Kshitij and Snigdha. They will present their work called OwnGoal, which is a recommendation system for spot viewership that acts like a real-time director using Marengo embeddings and mathematical mapping. The second presentation is going to be from Hemang, Akansha, and Ishika. They will present the application called WaitWhatAI, which analyze communication videos to flag clarity breakdowns with timestamp, actionable fix, and a rewritten pitch. And then finally, we'll have the group from Vishwath, Alexander, Mihir, and Carrie. They will present the application called Cadence, which is an AI-powered interview practice platform that help users improve both their technical response and communication confidence. Yeah. So as you can see, we have a wide variety of use cases of our technology, from spots to interview practice education to general HR hiring potential use cases. So yeah, super excited to hear from all the group and how you build TwelveLabs on the session. As for the audience attendees, feel free to send your question on the Zoom chat, and then the presenters can answer this question async, and then we'll also have a short, depending on timing, 3 to 5 minutes of interactive Q&A after the speaker finish. So with that, I will stop sharing my screen, and I will let the first group, which is the OwnGoal group. So Shriti and Snigdha, do you guys want to go ahead? Make sure unmute yourself as well.
Hi everyone, I'm Snigdha and I'm joined with my teammate Kshitij. We made this project for the SB Hacks hackathon this past month. I think we're having some trouble sharing. Just a minute.
All right, we can see it. Make sure to unmute yourself as well.
Yeah, sorry about that. So yes, back to OwnGoal. So this is a personalized sports broadcast routing, real-time multi-view embedding with TwelveLabs. So what we've all watched sports broadcasts our entire lives, But despite how much technology had advanced over the years, we watch it the same way. The way we consume any live game hasn't changed in 50 years. Everyone, whether you're a coach, a betting enthusiast, a casual fan, we all see the exact same camera angle at the exact same time. So we're using 12 labs to change that. We live in an era where there's hyper personalization. Your Instagram feed is different from mine. Your Netflix recommendations are unique to you. In fact, everything from YouTube to TikTok is personalized now, even your Spotify playlist. So, why, if we have 20 plus cameras in a sports game, then why should we just stick to one feed? So, behind this idea was where OwnGoal started. So, we used 12 labs to bridge this gap, moving away from static broadcasting towards a more intelligent content routing. So, when we think of AI in video, we usually think of discovery. So that's searching for a specific clip in an archive. With OwnGoal, we're introducing content routing. So instead of a broadcast director deciding one particular universal story for millions of people, OwnGoal will find the clips which are personalized to you. It's a real-time director. We aren't just finding just the clips. We are also dynamically routing the most relevant live camera feed to individual viewers based on their unique personas. It's the difference between watching a movie and being like a director yourself. So, to understand why this matters, look at these three viewers on the slide, sorry. The Fantic wants intensity. They want to see the sweat, the trash talk, the raw emotion of the star player after a dunk. Then we have a tactician who is like a student of the game. They want a high angle to see the defense and how it's rotating, how the space is opening up. And then we have a casual viewer who's just there for the vibes of the game, the crowd energy, the kiss cams, the viral moments. So these are three completely different audience spaces. So we can take it a bit more further than style. We can personalize it for loyalty, something which sports has a lot of. So, for example, if you're a diehard Lakers fan, it would route more Lakers-centric footage during the player intros, timeouts, the bench reactions, and this way you have your own personalized game. So today, a standard broadcaster tries to satisfy all these different audience bases at once, and as a result, we get single footage. OwnGoal uses this idea and 12 Labs embeddings to bridge this gap and give every fan their own personal director.
Uh, just a sec. Yeah. Hi. So thank you, Snigdha. To make this work in real time, we have built a recommendation engine that maps visual perception and human intent into the same embedding space. So it boils down to three different pillars. The visual For the visual perception, we use 12 Labs Marengo to generate the video embeddings for the clips and all the camera angles that are available. We also take in account the user persona. For right now, what we're doing over here is we are using users' own natural language preference to build this persona. And this also resides in the same embedding space as the videos. And the third key component is the director agent, which is like the brain. It calculates cosine similarity between these two different embeddings, and yeah, the between the live video feed, and it tries to make a routing decision every single second. Uh, so this is how the overall architecture looks like. If you look at the top track, the user, it gives a prompt. It suggests that what kind of things it likes right now. And based on that, we have a user persona generator that parses this intent and then generates embeddings for the user with the help of TwelveLabs Marengo. On the bottom track, we have multiple live stream video footages, and what we're doing with it is we are firstly taking in ingesting all this data and dividing into multiple small clips, and these small clips then again go into Marengo, with which we get the video embeddings. So these video embeddings are for a very small slice of the total footage, and multiply that with multiple cameras. So that's how many number of embeddings for video we have. So at the end, we have our own goal agent. So it performs a similarity match between the user persona and the live game footage. Based on that, it selects the view that should be visible to the user. So to give you a concrete, Snigdha, can you go to the next slide, please? So yeah, to give you a concrete idea on how the logic behind this is playing. So imagine two different kind of people who are watching the same game. At the 5 second mark, there is a player interaction. So the first user who is very enthusiastic, he gets the close up of the player interaction. And the analyst, meanwhile, gets to see the white camera, which might be playing the replay. So also during like a fastball action, the enthusiast might get a B-roll replay of the previous highlight, whereas the analyst might stay on cam 11 to watch the transition defense. So this isn't just a play. This is like a living, breathing broadcast that adapts to what you value the most. Uh, all right, moving on to the live demo. Snigdha, can you stop the screen share? I'll share my screen. The demo is my. All right, let's do it. Okay, so this is the app which so we can enter the user as well, but we want to see two different users side by side. So I'll just initialize this feed. We have a couple of videos which we have parsed. And meanwhile, this so it has certain intro part. So let's wait for that. Meanwhile, I'll just show you what we want to do with it. Yep. All right, so we can just move on to this. So on the left hand side, we have the video feed for the user one, which is the analytical user, and on the right hand side, we have the video feed for the enthusiastic user. And as you can see, is the left camera feed is focusing more on the players which are involved, the discussions that is going, whereas for the enthusiastic viewer, all we can see is the crowds, the lights, the players coming in, their entry. So that's one of the key things which we have worked towards. And yep. So what we can see over here is because of the Marengo, we have different embeddings, and we are able to capture these features, which tell us which user would be matching well with a particular video footage at a particular time. So we are changing the camera footage after every 15 to 30 seconds. So it was B-rep camera over here, now it's camera 2. And sorry for the blurry footage. It's the only free footage we could find for our demo. So yeah, back to Snigdha. Can you go back to the presentation, please?
Can you see my? Hi. Is my screen visible?
Yep, we can see it.
Yeah. So what we saw right now was the live demo with the live videos, and let's see how it works behind the screen. So this is what basically the director sees. It has different camera angles. We have a wide view, we have a close view, we have crowd view, coach, we have the referee. We're getting user emotions, and based on that, the director or the AI is choosing which camera angle to show which person. So this is like a prototype to for a better understanding of how this is working with four different cameras. And you can see the green is highlighting the camera, which it is choosing based on the user emotion. So going back to the slide, um, to wrap up our results, what we've really built here is a shared embedding space that bridges the gap between human language and raw pixels. So in traditional sport technology, you'd need thousands of manual tags to identify a tactical view or an emotional reaction. Using 12Labs Marengo, we're bypassing that entirely. We are now mapping the abstract user desires, what we call personalization for the viewer, directly onto the visual vectors in real time. Our director agent doesn't just find the clips in an archive, rather, it performs live content routing. We've essentially distilled the expertise of broadcast directors into a mathematical similarity function. This allows us to scale personalized production teams to millions of viewers simultaneously.
So over here, we are just scratching the surface. Moving forward, there are certain things which we would love to add to it. The first one being building an organic user persona. So instead of us telling what we like, the system should observe our behavior like it happens with TikTok and Instagram. So if we linger on a replay, the embedding updates should be to prioritize more replays. And again, another key feature which we would like to implement to this is high stakes detection. So even a tactician maybe wants to see a game-winning buzzer beater from the best angle. So we are building a priority override. So that identifies these clutch moments where the system routes the highest intensity angles to everyone. So, regardless of their persona, no one should miss the history-making shots. So, yeah. So, OwnGoal is about making sports more personal and more engaging through the power of multimodal AI and 12 Labs Marengo. So, thank you, everyone. Thank you, 12 Labs, for the incredible tech that made this possible. And you can find our contact info and project links in this QR. All right. That is it.
Awesome.
Thank you.
All right, thanks, Guy. Really appreciate the walkthrough. I think it's a really cool demo for very relevant use cases of our technology. Um, yeah, for the attendees, if you have any question, feel free to either ask live or like put on the chat. Um, I do have one question, about on the technical side, how's your general experience working with Marengo embeddings, and how did you do the mathematical mapping in order to direct the similarity score? Can you go a bit deeper into embedding space and how you manipulate that?
So we were looking at two different embeddings which we wanted to generate, one for the video and another one for the user intent. So it was
Mhm.
very convenient that we were able to generate for text, which was for the user, and for the video at the same time. So overall, it has been like a fairly smooth experience. Like we just plugged in the videos and it generated the embeddings later on, which were then ingested by the agent. So yeah, overall, it has been like quite helpful with the product.
I see. Is there any like technical challenges of taking the raw footage in low resolution and processing that with 12 apps? And how do you envision making like improve the quality of the experience, for the future? Yeah.
One of the things which quite matter over here is it processing live.
Mhm.
So one of the things which we expect to happen soon, like maybe we can have a VLLM which processes the embeddings, processes the videos and generates the embedding very fast at scale. So this is for sure something which we would like to scale further in terms of sp the generation of this, the speed of the generation. So yeah, that's something which we look forward to.
Awesome. Um, okay, yeah, thanks, Guy, for walking through the demo and presenting it. I think it's a very, very, very technically adapt, you know, usage of our embeddings model. With that, I would like to have the second group to start presenting. So with Heyman, right, and
Oh,
Ishika and Nakasha. Do you
yeah.
guys want to go share the screen?
I'll share this.
And then for any other question from the previous presentation, you can just ask on the Zoom chat, and uh, Kshitij and Snigdha should answer via Zoom. Yeah,
Should
go
we
ahead.
go now?
Oh, no, no, you should answer it via
Oh,
the chat because
okay,
we
okay,
have,
gotcha, gotcha. Yeah, thank you.
Hmm? Hello. Um, am I audible?
yes, we can hear.
Okay. Hello, everyone. Thanks for having us. We're excited to share Wait What, a project we built on top of 12 Labs that turns raw demo and pitch videos into time-stamped clarity feedback. It's an AI system that watches your demo or pitch and tells you with timestamps where your audience could get confused and how you can fix it. The goal here isn't better video editing, it's better communication, and 12 Labs has made that possible. So anyone who's practiced a pitch or a demo before has definitely felt this, that you finish recording and you watch the recording back and think something's off, but I don't know what, I don't know where. So you either rewatch the whole video or ask someone else for feedback and then you fix it.
I think she just cut up a little bit. Hemang and Ishika, do you guys want to take away?
Yeah. So clarity, it doesn't fail evenly across the video because you can just be confident in the starting and it might just go a little bit bad at the bit in some between. So it breaks at very specific moment. So say when jargon spikes or when the claim lack evidence or when the structure is it just jumps ahead of you. It's like, and those moments only make sense with the context. So who the audience is or what the goal is of the pitch and what's happening visually at the exact that second. So that's why the text only tools fall short when giving you the feedback. So to actually diagnose clarity, you need to understand the video as a timeline, not just transcript. So, and that's where the multimodal understanding becomes essential. So, coming to what if our video could point to exact timestamp and say, so this is where the clarity drops because, and here is so how to fix it. That's it. Just tells you pinpoints you to the exact moment where the clarity drops. It explains why your audience got distracted or confused, or it suggests you what you can just change instantly there. Now let us show you a quick demo to demonstrate how this thing works.
I think the audio is not audible.
Um, 1 second. Is it audible now?
No.
It's uploading the video.
I'll just stop the sharing and start again. 1 second.
Yeah, when you share via Zoom, make sure to click share sound. There's a button to click share audio, share sound, and do that. Okay, yeah, we can see your screen. It's still processing the video.
Sorry?
It's processing the video. We can see your screen.
Okay. Yeah. Can you hear us? Once
No,
I'll just
the audio isn't audible.
Wait, what audio?
There's an audio to the video.
sure, can you take over if you want? Don't think the settings are working.
Okay, just a moment.
Yeah.
So when you practice a demo or a interview pitch or something of that sort, it might sound that it's unclear or something didn't land as we expected. So the problem is no one can tell you where the clarity dropped or where the clarity breaks. Okay, can you pause the video for once? Yeah. So this is WaitWhatAI. It's an AI system that analyzes your demo video and tells you at exact timestamps where your audience gets lost and how to fix it. So as you can see, this is where the flow starts. So you upload a demo or a pitch video here. This could be a startup page, it could be an interview answer or a product walkthrough. And then, so yeah, you can play the video now. So as soon as the video uploads, we send it to TwelveLabs, and TwelveLabs gives us a time-aligned transcript and reliable video indexing, which is the foundation of everything that follows. So it takes a little moment to upload the video here on the website. And then next we choose the tone of the suggestions that we need. So kind is gentle and encouraging, honest is balanced and direct, and brutal is intentionally blunt, and it tells you exactly what's not working. Next, we also have this optional part which kind of establishes the context. So you can choose the domain, the time limit, or the goal of the pitch, and kind of give a context on what you're trying to present through the video or the pitch or the product walkthrough. What's clear to an investor might not be clear to an engineer. So the system accounts for that and suggests feedback accordingly. And then once you hit analyze, it starts processing the video here. So first we use TwelveLabs API to get a time-aligned transcript and reliable video segmentation. So every word is tied to an exact moment in the video. And on top of that, we run a series of LLM-powered analysis that are designed specifically around clarity and are not just generic summaries here. Now we are on the results screen. At the top, you would see a clarity score and tier. This gives you an immediate sense of how clear or confusing the demo is overall. You can also change the intensity of the suggestions from here as well. And on the right, you will see one of the most useful outputs of the system, the timestamp clarity analysis. Each issue is tied to an exact moment in the video. So you're just not getting a feedback, but you also get the exact timestamp where the clarity dropped. And you can jump straight to that moment by clicking on that, and you can fix and move on. And then below that is a timestamp heat map, which gives you a visual overview of clarity across the entire video. So the darker sections mean higher confusion risk, and that's where the clarity drops the most. And then on the side, we also show a signal breakdown. This tells you why the clarity issues are happening. For example, buzzword overload, grouping gaps, claims without evidence, or structural problem. And these are weighed according to severity. So the most serious issues matter the most, and the minor ones do not impact the feedback as such. And we don't stop at telling you what went wrong. So we also generate a feedback and offer an optional rewritten version of a whole pitch. So this rewrite is not just random; it's generated by applying the exact fixes we just suggested across the entire pitch. So every change maps back to a detected clarity issue that we just showed on the website. So we can think of this as a diagnose first, explain second, and rewrite last kind of a situation. So that's WaitWhatAI that shows you where clarity drops, why it happens, and how to fix it. Yeah.
So this project would not exist without 12Labs because at the core of WaitWhatAI is the ability to trust the video understanding and how. So we rely on 12Labs Marengo API for the three critical things here: the accuracy, the time-aligned transcript, and reliable video indexing. Also the segment level retrieval. So this means when we say clarity breaks at 42 seconds, we know exactly that the timestamp actually matches with the said time and what's shown there. So because of that reliability, we were able to focus on building higher level clarity analysis instead of just fighting over the video infrastructure and transcripting it on our own. Moving ahead to this was developed by a collaboration between me, Akanksha, and Ishika. Yeah, that's all. We are open for the questions.
All right, thanks, Guy. I realized UI UX of the application, very interesting flow and I think the visualization of like the metrics, right, of how communication breakdown put a very like clear signal for the end user on how to improve. What are like some of the like big technical challenges that you encounter with our API when debugging this is the this application?
Uh, so initially when we started using it, we weren't much aware of all the possibilities that we could go. So we did miss one of the things with your APIs because maybe we didn't go to the documentation properly. So we wanted the GenAI to say go through all the transcripts. So we used 12 API to get the transcript of the video, but we used Gemini API separately to analyze the whole thing, give it different prompts, generate what all results we need. And later, when we were talking to one of your developers, we realized, okay, this is something that was possible to directly that we could have leveraged the 12Labs API for it. That was something we weren't aware of in the starting. So I was say that would have just made it much more easier for us to integrate things and would have left more time for the things that we planned. But other than that, I think the bandwidth was not much of an issue. We thought initially that we were hitting the API limit, but later we realized that it was some other issues that we were facing. So yeah, that's all.
Gotcha. And I know like a big part of this is also like using our model to extract transcript, right? With precise segment level timestamp. Did you run into any specific issue on like get the reliable output based on the request?
We did try multiple different videos and we didn't face any, I mean, we didn't see any situation where we thought that, okay, the transcript is not matching the, say, the audio or the video. We did realize that, so we tried different multiple AI voices over it. So when there was too much accent use, I would say it was missing few of the points. It wasn't able to transcribe exactly what they said. So it would just misjudged few of the words, but most of the points, I think it was fine. It was just some really strange accent, if there is one that at that point, it might just fail a little.
Gotcha. Final question is, like if you have to improve for like future, like if you have to like, continue building this application, what are other improvement on new features that, you think could make the application even better?
So few things that we thought about were have some visual impact. So for now, we do analyze the whole video, but we are not relating what, say, a person is presenting a presentation. We are showing some slides and he's saying side by side, but we are not comparing what he's saying is exactly what he's showing. So we were thinking we can have one of that as a feature that it can detect. And then one more thing that we are thinking of is it can analyze the person's body language if he's nervous or if he's using too many hand gestures while speaking, or he is, say, overclaiming something. So one of those things also we can analyze. So we would love to work more on the video side. And yeah.
Gotcha. So like not just the audio and verbal
Yes.
aspect, but also like kind of the visual signals and, you
Mhm.
know, like hand gesture and facial expression, those kind of thing to,
Mm.
to like provide even like
Yeah.
more fine-grained analysis, like recommendation of the speaker quality, right?
Yes.
Great. Awesome. I think that's it for the second group. Thanks, guys, for walking over the demo and present the application. Very relevant and clear example of how like our Pegasus model can be reliable for timestamp and transcript generation and also like you know like potentially impact on how can you use it with other large language model as well for your workflow. Yeah.
Thank you.
With that, I will let the final group to present, Cadence group. Whoever take the lead, feel free to unmute and start sharing your screen.
Okay. Hi everyone. Thank you for having us. We're excited to present Cadence, a multimodal interview evaluation system we built at SB Hacks using 12Labs Marengo for video understanding. Cadence evaluates not just what someone says in an interview, but how they say it, by combining large language models with semantic video analysis to score both technical correctness and behavioral confidence. Since interviews are multimodal, we think that the evaluation should be as well for the most effective feedback. The problem statement. So technical interviews are much more than merely correctness checks. Interviewers evaluate your reasoning process, your clarity under pressure, and your confidence and presence in general. And even more specifically, confidence is measured through many body language indications, such as eye focus, posture, repetitive movements, and how steady or restless someone appears. These are signals humans can naturally pick up on, but current prep platforms almost completely ignore them. Most interview prep tools today focus on speech-to-text transcription and semantic scoring of answers. And although very useful, it misses a huge dimension that interviewees are looking for. Without video analysis, systems can't detect repetitive nervous gestures, and visual distraction or disengagement. So users get feedback on content, but also on presence, and in real interviews, how one presents themselves is very important. This gap is what motivated Cadence. Cadence is a full stack multimodal pipeline. On the front end, users choose an interview topic, record a video response directly in the browser. And on the back end, we split up our data collection. So for audio, we use Gemini for transcription, language evaluation, and speech analysis. And for video, we use 12Labs Marengo for behavioral understanding. Then we fused all signals into a unified performance and confidence score. This mirrors how human interviewers think in a holistic sense. So Cadence simultaneously evaluates semantic correctness of answers, temporal speech patterns, and visual behaviors such as movement and eye focus. Okay, now off to Fish.
Yeah, so we built the front-end UI of Cadence with Next.js and Tailwind CSS. When a user clicks record on the website, we'll capture a web and video file, and we separate the audio and video streams on the client side. We then upload both of the streams asynchronously for analysis. And this design basically allows us to process the different modalities in parallel, which keeps us running. Yeah. Next, we'll go to the audio processing. We use Gemini 2.5 Flash for fast transcription, which we then return to the user as a transcript for reviewing. We then prompt Gemini to annotate the transcript. So it'll mark down filler words like and like. It'll mark down when you pause for an extended period of time. And it'll also have markers for when you seem hesitant. So these markers basically become quantitative indicators of how confident you are verbally. So we're able to add to our confidence evaluation score by processing how smoothly your candidate says the response. Next, we evaluate the technical quality of the answer. Gemini compares the transcript against the original question and scores your correctness, completeness, and clarity of reasoning. So in the end, like if you give out, your response, like Gemini will give you back something like, oh, you had good intuition, but maybe your explanation lacks structure. So that's about it for the verbal performance component of Cadence. So next we'll go to the fun part, which is the video analysis. So this is the part that most systems don't take into account yet, but yeah, so confidence, right, isn't something we can detect in one individual frame, but we get a sense of it over time. So we can see that through patterns in the interviewee. We see them like maybe repeatedly fidgeting, their posture shifting, or them making frequent breaks in eye contact. These behaviors correlate strongly with how nervous you seem to the interviewer. Traditional computer vision doesn't really work here because it's usually based on rules that are checked frame by frame, and we needed a system that's able to understand behavior semantically. So that's where TwelveLabs Marengo comes in. We send the full video recording to Marengo, which performs a high-level video understanding on it. Instead of just detecting motion or pose, it can understand your behavioral patterns, your consistency, and transitive movement and posture across the entire clip. This lets us reason about confidence as sort of behavior. Next, from Marengo's outputs, we are able to compute visual confidence metrics, such as variability in movement, visual stability, and overall behavioral consistency. Higher variance in movement suggests that you're nervous. Stable posture and focus suggests that you're confident. We turn this into a visual confidence score grounded in video analysis, rather than just markers that we sort of made and wrote down. Okay, so this is where we combine everything. Cadence basically fuses the speech disfluency metrics that we got from Gemini with the visual confidence score from TwelveLabs and creates our final confidence score and evaluation. Instead of presenting the results from Gemini and TwelveLabs separately for the confidence part of it, we generate one score that reflects real interviewer judgment, where speech slip-ups and visual confidence both interact with each other. This is the main part of Cadence, yeah. You can, Mihir, you can go next, yeah.
Thank you, Vish. Rather than just solely give back the feedback as raw metrics, Cadence is able to translate signals into actionable feedback, such as strong answer but frequent head movements reduce perceived confidence, or correct solution with excessive pauses during explanation. Our product uses well-designed prompts in order to maximize the helpful feedback a user receives. And now on to Alex for a short live demo.
Sorry, 1 second. Awesome. Okay. So this is our website, and as you can see here, we have a section where you can pick the actual interview type, and we have a bunch of preset questions that you can pick from. And it's important to note that we actually have behavioral questions, and it can analyze them very well. Such as what motivates you in your work, and things that have more ambiguous answers. And then for now, I'm going to do a custom question here. And for the live interview, I'm going to be answering how to check if a string is a palindrome. And for the sake of the actual demo, I'm going to do this very badly. I'm going to do the wrong answer, and I'm going to look really unconfident while doing it. To check if a string is a palindrome, what you'd want to do is you'd take a palindrome is where you have a variable that can only be positive, but it can't be negative. And yeah. And so that was very bad, obviously, but now let's see what our software thinks of it. And this generally takes about 20 to 40 seconds, so not too long. And so as you can see here, it's transcribed it and done the technical check, and now it is just waiting on 12Labs to finish the confidence evaluation. Awesome. So as you can see here, we begin with a transcript that shows all of our filler words and large pauses. And so as you can see, I did not do too great here. Then I got the question completely wrong. It's just telling me 0 out of 10, just completely wrong and not a variable type in the slightest. And then if you go to the confidence evaluation, this is where 12 Labs largely comes in. And we have a 4 out of 10, a lot of long pauses, a lot of filler words, minimize hand movements, and a lot of just frequent filler words, not great. And if you go down here, you can actually see a confidence trend over time. So after my next session, which I'll show, you can actually see improvement and you can see your recent sessions. And so yeah, now I'm going to go back and do a better one where I'm going to answer the time complexity of a binary search. The time complexity of a binary search is O of log n. This is because the dataset halves every time you search for it, which means that if you double the amount of data, then it only increases the amount of iterations to search through it by 1. And now, that one is shorter, so it should be shorter, but it will give us the score. Here you go. So as you can see here, the correctness is right, and it gave a little suggestion about clarifying n, but overall I got it right. And the confidence evaluation is much better. So as you see here now, you can see improvement of the scores and overall actual better filter control, delivery, and yeah. So I'm gonna go back now to the slides, and Mihir, you can take it from here.
All right. We believe Cadence. Can you mute? Yeah, I got you. We believe Cadence extends far beyond technical interviews. It can assist speakers with presentation rehearsal or even confidence training for remote communication. Anywhere confidence matters on video, we believe Cadence's evaluation can help. And while building Cadence, we explored traditional computer vision approaches. However, they rely on frame-based pose detection or handwritten behavioral rules. The problem with these approaches is that they don't generalize to complex inputs. 12Labs' models allowed us to analyze video semantically over time, which is exactly what confidence assessment requires. This shifted our system from motion detection to actual behavior understanding. And we see Cadence evolving into a behavioral training platform. We hope to be able to track long-term trends in verbal fluency, posture, gaze, and confidence. And we also want to be able to analyze specific user habits. We also hope that Cadence is able to adapt across different contexts, such as technical interviews, presentations, or even leadership coaching. Thank you so much for listening, and we are now excited to take your questions.
Hi guys, really cool demo. I love the live testing and evaluation of application. It looks like it running in real time, and the indexing is quite fast. So we got like 5 minutes left. Maybe can you just talk about some like technical challenges that you encounter during the process of using TwelveLabs? You mentioned that the confidence score, right, is the most important part. And any workaround or like things that you have to do to make sure that the confidence score is compute correctly?
So in order to make sure the confidence score is accurate, we had to go through multiple different prompts. So we tried a bunch of different prompts. We told 12Labs what to look for, and like we also gave it a range where like like a 3 out of 10 would be this kind of like response, and a 7 out of 10 would be like this kind of response with a lot more confidence. And that allowed the 12 labs model to not only give its like own opinion, but use like an objective metric, which is consistent over time.
I see. So you like consistently refine the formula, right? To get to iterate the formula so that the confidence score can become more accurate over time.
Yeah, we had like around 10 different iterations of prompts in order to get like a accurate confidence score.
We also initially didn't use the Gemini as part of the confidence evaluation. We were just using the TwelveLabs, confidence evaluation, but we realized that in addition to giving the video score based on like the video, how confident you look from the video, we're also adding, the filler words and the pauses into our, like formula for creating the confidence score, improved our results a lot.
Mhm. Yeah, so like Gemini here transcribe the audio, right? And then that output, after being labeled with filler words, would then that you basically use the LLM from Gemini to like provide feedback.
Yeah.
And then Marengo is a separate stream, right? For the confidence score, tendency, etc. on the visual information.
Correct. Yeah. Yeah. So Marengo makes a visual confidence score, and then Gemini makes both the technical evaluation and a verbal confidence score. We put the two visual and verbal confidence scores together to give you one confidence score overall.
Nice.
Yeah.
I think another aspect of this project is just really cool is the UI UX component. Very clean and modern user interface. And like in that demo that Alex just did, right? There's option to choose from, and there's a live webcam as well. Can you walk through the kind of end-to-end process of building the full stack application and design choice that you made, so that like it can resonate, right, with actual folks who are practicing for interview?
So we use Next.js to build our like front end UI, and we also we're able to use like API routes in order to send the video between like a client machine and a server machine. And then once we have like a backend server that's running like Node.js, it receives the video and then it packages up into two streams. One of the streams is sent to Gemini, one of the streams is sent to 12labs. And the reason we chose to use Next.js is because it allows us to streamline everything into one language, into one code base, and not have like issues with like one version not working with the other. It was all like fluid and worked well.
Yeah, there's like no separate database for this thing. It's like the UI, the front end, the back end are sort of like combined for this project. Yeah.
Great. Final question is, if you have to improve this application for future iteration, what new features or specific prompt or system design things, right, that it can use to make it better?
Yeah, so one big thing we'd love to add is when you go to the actual feedback, we'd love if it actually could give a timestamp. And this is something we want to work on in the future, but it could give a timestamp of exactly when you move your hand. Because right now it can give feedback about, oh, used good hand gestures. But I wish we want in the future to be able to highlight where like a green little timestamp where it shows what you did good, what looked good, and then something like a red timestamp where it will show, oh, you looked really unconfident here. And so that's probably the biggest thing. And then also, right now, all of our trends are localized just on our browser. And so in the future, it'd be pretty cool if we'd like to add a login system or so user system where they can actually have their data saved across multiple devices or not just saved locally in the browser.
Gotcha. Yeah, so well, I think for the first part, like if you play around more with our Pegasus video analysis model, you can prompt it to look at the timestamp and then like zoom into that, right? So, and then after you figure out those timestamp, right, thing like you can do some sort of like clip extraction visual indicators to intersect the raw video with some sort of visual indicator, right? Like a timeline demonstration in the front end. Yeah, and as for I do like the fact that you mentioned like local. Yeah, I think that's a tough challenge, right? Apply doing everything in local. But yeah, that's something that I think our team is looking into about like how can we bring these capabilities beyond the cloud actually to edge device and cameras and mobile phone, all that stuff. So that's definitely on the roadmap in the future. So that's a great suggestion. All right, I think we're just out of time. Thanks again, the Cadence team for a very nice demo and walkthrough of the application. And yeah, thanks everyone again for joining the session today. Thanks for the folks who be presenting all three groups. OwnGoal, WaitWhat, and Cadence. The recording of this session should be available on YouTube probably by early next week. So be sure to send that recording to everyone. You can share that with your friends and showcase what you have been building with cool technologies. Over hackathons. And yeah, like we've been running this webinar session on a weekly basis. So if you find this interesting, feel free to turn into upcoming session, see more projects, see more application, build our tools, and yeah, hope to connect with the community and you engage local, loyal developer community for TwelveLabs. Thanks everyone, and hope you enjoy the rest of your Friday.
Thank you so much.
Guys.
Thank
you
you.
for having us. Yeah, have a good Friday.
Cheers.